So we discussed the memory as part of computer fundamentals or computer units that you find in a computer. So memory is now where we discuss the three categories of memory. But before we go there, we say that a memory is like a human brain. It is used to store data and instructions. Computer's memory is the storage space in the computer where data is to be processed and the instructions required for processing are also stored in the computer. The memory is divided into larger number of small parts called cells. So the smallest unit of memory is called a cell, and that is it is one cell stores 1 bit. And you might be very conversant with the computer memory storage units, whereby you talk about a kilobyte. We normally start with kilobits, then kilobyte. This is KB small. Then we talk about megabyte. Then we talk about gigabytes. And then talk about terabytes. I think that is where we are now. But you might find more advanced versions of memory units. We are saying the smallest unit of memory is called a bit, and it is stored in a cell. Each location or cell has a unique address. So if you have a very large memory, the smallest one is called a cell, and it will have an address. You might call it address 1, address 2. And these addresses are normally given by hexadecimal characters. We are going to discuss that one at a later stage. So you might find that X0X0000001 is our first memory address. Then as you carry on, as you move on, you have very many cells, and each of them has different address. Of course, you're saying that each unique address varies from the 0 to memory size -1. So if you have a memory size of 1 kilobyte, 1 kilobyte is about 1024. You're going to be having memory addresses starting from 0 all the way to 1023. For example, if the computer has 64K words, then this memory unit has 64 times 1024. We said 1K is 1024. That's something that I might have taken it to be obvious, but this is something you'll know, that 1 kilobyte is 1024 bits. Okay, so when you say kilobit, talk about 1024 bits. When you talk about kilobyte, there's a difference between bit and byte. You'll see those details later. When they say 1024 kilobytes, then we say there are 1024 bytes. So we are saying that 1K words, which when you say words, 1 word is equivalent to 1 byte, then that is why you're saying that we have 64 times 1024 memory locations. The address of these locations are going to be from 0 to 65,535. We have -1 here. That's why you're saying it is -1. Okay, so that is a brief introduction to what memory is. And now we're saying there are 3 types of memory. I have mentioned this one before: cache memory, primary memory, and secondary memory. So we start with cache memory. Cache memory is a very high-speed semiconductor memory which can speed up the CPU. The key word here is this one. It acts as a buffer between the CPU and the main memory. So CPU is talking about the processor that has the ALU and the control unit. The memory is the one that is storing the data for processing. So this is a buffer. It is used to hold those parts that are immediately being processed and the program which are frequently being used by the CPU. The parts of data and programs are transferred from the disk to cache by the operating system where it can access them. So here is the idea. We have the main memory. So the operating system or the programs run inside the main memory. And this is where we say that a computer cannot work without main memory. It can work without secondary memory, but it cannot work without main memory. So they operate from here. Like we have two boys who are fighting their programs, and they are operating inside a ring. So the ring is the one you're calling the main memory. Okay, but now the specific space where each one of them is studying or sitting is the one that is going to be called the cache memory. I am just using an analogy so that you don't get confused. So I think I might also give you another example. You have someone who is on a table, seated down, and they are eating. They are eating on a plate. So the food is on a plate. So this plate is the one we are calling what? We are calling main memory. But then they chew one bit at a time to their mouth. So the small memory that is in the mouth for chewing, we can call it the cache or the cache memory. So it is a very high speed memory that allows you to process. Assume chewing is the processing. You process. Once you are done with that, you swallow. You swallow your food. Then you fetch some other chunk of food. So that kind of memory is the one that we are calling it a buffer or a cache memory. It allows you to fetch the most urgent or most immediate data that you want to work with for processing. That is one that is called cache memory. So I think I have given you two analogies, and these are they are sufficient. So the advantages of cache memory. So this is how the cache memory looks like. It's normally very small, very expensive, and very fast. So I think that even is characterized here. The advantages of cache memory is that it is faster than main memory. It has less access time. Access time is the time that you require to fetch data from where it is to another location or to the processor. It is much less access time, therefore it is faster. It stores the program that are being executed within a short period of time. It is normally used for temporary use. So it is just like the mouth. You are storing the food temporarily there for chewing. The disadvantage with the cache memory is that it is very expensive and it has normally very small. So you cannot have about 100 GB of cache memory. We talk about 1 GB, 2 GB of cache memory maximum, and you find devices that are even having 512 MB of cache memory, even less. So it is normally very limited. The most common type of memory that you have is called the main memory, and it holds that data and instruction in which the computer is currently working on. Now this is like the plate. We are fetching from the plate, putting it in the mouth. So if we say mouth is the cache, notice this is the analogy, not necessarily the case. Then the plate is the main memory from which you are fetching what you want to eat from, and then the sufuria is your secondary storage. Main memory is also called primary memory, and therefore we are saying that this is where we hold the data and instructions on which the computer is currently operating on. It has limited capacity also. It is not as huge as the secondary storage. And data is lost when power is switched off. It is generally made up of a semiconductor device. Solid state devices are the one that make the primary memory. Sometimes we might also have HDD, but this depends on the kind of computer that you are using. But the whole idea is that the main memory is where we hold the data that we are working on currently. Just like the plate holds the food that we are eating currently. Now, these memories are not as fast as registers. Registers falls under the category of cache memory. The data and instruction required to be processed resides in the main memory, and then it is divided further into RAM and ROM. Now you might have the idea, when you are buying your phones, you normally talk about a 2 GB RAM phone, a 4 GB RAM laptop, a 1 GB phone, etc. The ones that are normally nowadays rephrased as 1 GB, 2 GB, etc. These are phones or laptops. They are normally ranging between this one. The most advanced one I am seeing nowadays might be 16 GB. These are very fast. If you go to your computer and right click, you go to properties, it will show you. You can see clearly here, this is what we are calling RAM. I want to make sure that you don't get confused with the ideas that the things they are talking about are strange. This is RAM, this is random access memory. It is part of main memory. Mine is 8 GB. You might find other computers that have 4 GB, 2 GB, 1 GB, etc. In the old days when I was in college, we used to have even 512 MB or have a GB being used. So I just showed you the RAM, and it is one subcategory of main memory. There is another called ROM, and we are going to discuss that. So this is how they look like. We said they are made by solid state devices or semiconductor devices. The characteristics of main memory are as follows. They are semiconductor memories. We talked the difference between semiconductor memories and the others are calling them magnetic disk memories. These are very, very slow. These are very fast. So we are saying that they are normally magnetic semiconductor type of memories. It is also known as main memory or primary memory. So the idea you are introducing here is that they are primary or main memory. It is volatile. Volatile, this is the one section of RAM, is one that is volatile. When you talk about, we have said there are two categories, ROM and RAM. So RAM is normally volatile, ROM is not volatile. So sometimes we say that main memory is volatile because RAM holds the biggest portion of the main memory. Data is lost when power is lost or switched off. So that this is the category or the category of RAM. And the idea is this: think about a calculator. Calculator is a type of a computer. So it has two types of memory. One of them is RAM, and the other one is ROM. So where you have installed all the instructions such that it knows when you are doing plus, when you are doing sign, where you have saved the operating system of a calculator, so to speak, operating system. That is where the instructions run from. That is called ROM. It will never get lost even when you have switched off the calculator. Whenever you turn it on, it will still know how to operate as a calculator. But when you're operating the normal operations like 1 plus 1 or 1 plus 10, it will know that the answer is equal to 11. If you continue working, you try to look back, what was the earlier calculation that you had, to still remember that you had done 1 plus 10. But if you switch off the calculator, this 10 you never find it, this 11 you never find it again. That is what I mean by data being lost when power is lost or when it is switched off. So that is the idea about RAM and ROM, and I think I have really introduced that. So it is faster than secondary memory, again because of being semiconductor. A computer cannot run without the primary memory. So a computer cannot run without these two. It must have RAM, some instructions that are permanently stored. They are stored in a place of memory called ROM, and where the computer puts the temporary data as it processes it is called RAM. So now let's talk about secondary memory. And you see now that this type of memory is known as external memory or non-volatile memory. It is slower than the main memory. They are used in storing data and information permanently. I want you to get this very accurately. This is permanent storage, but not for the computer operation. We say for the computer to operate, it requires some permanent instructions to be stored somewhere. Like a calculator requires always to remember what a cosine means, what a plus means, what the equal sign means, etc. So that is stored in a place called ROM. But when you talk about a computer, you have a hard disk. I know you might be conversant with hard disk. Talk about where you save your photos, where you save your movies, or where you save your notes. You normally save this information in a hard disk. And that hard disk is where we call HDD or hard disk. So that where you store your information permanently, you can find it tomorrow or the other day, even after you have powered up your computer. That is called secondary memory. Sometimes computers share main memory with secondary memory. So that is just the depending, but what you just need to remember is that a computer can work without a secondary memory as long as it has a main memory. It has somewhere to operate from, and it has somewhere it has stored the permanent instructions. So CPU directly does not work with this kind of memory. It has to be fetched into RAM so that it can be processed. Instead, these ones are accessed via input-output routines. So the routines that fetch the data from hard disk, put them in RAM. So you normally fetch data from hard disk, put it in RAM, then computer operates with this one. Once it has finished, puts it back into hard disk. That task that do this are the ones that we are referring to as the input-output routines. The contents of secondary memory are first transferred to the main memory, that is what I've just said, and then the CPU accesses that. So the examples of secondary memory are hard disk, like the one I'm showing you now, CD-ROM, DVDs, flash disks, etc. So the characteristics of secondary memory include the following. They are normally magnetic type. They are magnetic disk. You know, I talked about this one before, whereby they use the operations that whereby we have a disk that rotates. If you open up these nuts, I don't want you to do that. You are going to find a disk here that rotates, and there is a head that moves between the center. There are tracks that go around, and therefore some data is stored here, others is stored here, others stored somewhere here. So it rotates, accesses these tracks, and therefore knows or able to fetch the data that is stored inside there. So the idea is that this one that we call magnetic disk, and it's a bit slower than the solid state that works that category. So anyway, it's also called backup memory. That is the secondary storage. It is non-volatile. You will not lose data even when you have lost power. Data is permanently stored. It is used for storage of data for a computer. A computer can run without this hard disk, and it's slower than primary memory.